Let's do some integral theorizing. So this is the evolution of evolution, if you will. This is an idea I've been playing with for a little while, and I quote, "In the American vernacular, theory often means imperfect fact, in part of a hierarchy of confidence running downhill from fact to theory to hypothesis to guess. Thus, creationists can and do argue, evolution is only a theory, and intense debate now rages about many aspects of the theory. If evolution is less than a fact, and scientists can't even make up their mind about the theory, then what confidence can we have? Well, evolution is a theory, but it's also a fact. And facts and theories are different things, not rungs on a hierarchy of increasing certainty. Facts are the world's data. Theories are structures of ideas that explain and interpret facts. Facts do not go away when science debate occurs. So Einstein's theory of gravity replaced Newton's, but apples did not suspend themselves in midair pending the outcome. And human beings evolved from ape-like ancestors, whether they did so by Darwin's proposed mechanism or by some other. And that's exactly what we're going to discuss. That was Stephen Jay Gould. This is a theory that evolution itself evolved through different waves or stages of development. So the goal here is to show that there are a number of varieties that evolution comes in, if you will, a number of different packages. Evolution itself is evolving and complexifying through sentient beings. My theory will be that natural selection is just one of the packages that evolution comes in. I will posit that there is physical evolution, that's one style of evolution, the evolution of matter. The second one, an evolution within early life, where there's asexual reproduction. A third one where evolution occurs through natural selection. A fourth one within cultures, where we have mimetic memes that form. And a fifth one is like a super meme, wherein we understand the nature of conscious evolution and therefore can add directionality to the process of evolution. So, here we go. Starting with the first kind of evolution, physical evolution. I would separate this into two parts. The first deals with the periodic table, and the second with crystals. So, and I quote, "Progressing through a group from lightest elements to heaviest elements, the outer shell electron, those most readily accessible for participation in chemical reactions, are all in the same type of orbital, with a similar shape, but with increasingly higher energy and average distances from the nucleus. So for instance, the outer shell or valence electrons of the first group, headed by hydrogen, all have one electron in its orbital shell. In hydrogen, that s orbital is the lowest possible energy state of atoms, the first shell orbital. But when you get into francium, the highest element of this group, the outer shell electron is the seventh shell orbital, significantly further out on average from the nucleus than those electrons firing in the shells earlier. So there are more electrons and greater energy the further along one goes within the periodic table. Both of these trends, although perhaps subtle, point, I believe, towards greater complexity within physical matter. There is, in other words, seemingly a complexification within matter, which can, in other words, be considered matter going through a process of evolution. So now to crystals. Inorganic matter, if free to take the physical state, and I quote, in which it's most stable, always tends to crystallize. For a crystal or crystalline solid is a solid material whose constituent atoms, molecules, or ions are arranged in an orderly pattern extending in all three spatial dimensions. So, if it's a case that inorganic matter will tend towards its most stable state in crystalline solid state, the most stable state of inorganic matter in crystals show greater complexity over other matter insofar as it's repeating patterns in the three spatial dimensions. therefore have a case to show that there's evolution within matter itself. Let's skip some here and just go on to crystals, or to asexual reproduction. So in early life, we look to many of the single-celled bacterial organisms that produce asexually. So unlike multicellular organisms, increases in the size of bacterial or cell growth and the reproduction by cell division are tightly linked in unicellular organisms. Bacteria grow to a fixed size and then reproduce through binary fission, a form of asexual reproduction. That's a quote. So, although gametes play a role in the process of change within these early life forms, what's happening here is pre-natural selection, if you will. And the other one of matter was also pre-natural selection. So what can these life forms do that physical matter could not? Well, for one, create essentially replicas of themselves very quickly and efficiently. And that's something that matter could not do. Where does it fall short of the sexual and multicellular production? Well, I mean, they're not. There is asexual multicellular production, but where does it fall short of sexual reproduction or natural selection proper? Current hypothesis suggests that, well, asexual reproduction may have short-term benefits when rapid population growth is important to stable environments. Sexual reproduction offers a net advantage by allowing a rapid generation of genetic diversity, allowing adaptation to change environments. In short, multicellular sexual organisms that take advantage of natural selection for genetic diversity emerge and evolve quicker than asexual organisms do. So, this is just to play around with the idea. You have an air plant, and right next to it, another air plant emerges through this asexual process. But this new air plant comes sort of fully from the seed of only that one air plant. So how new can this new plant be? It stretches the idea of individuality of that plant being a new air plant. Does it really make sense to call this natural selection? I think not, as the newness of the new air plant is coming solely from that one organism. So let's move on to the typical natural selection. So this is the sort of third wave of evolution. So Darwin's theory of evolution by natural selection hinged on the idea that advantageous traits in an organism would enable it to better adapt to its environment and thus survive and reproduce. But he could never figure out how these traits were passed on from parent to offspring. So I quote, "It wasn't until 20 years after his death when scientists unearthed Gregor Mendel's discovery of genetics that an answer was found. Through the marriage of Darwin and Mendel's ideas, the neo-Darwins created what's called the modern evolutionary synthesis. The evolution really boils down to this competition of genes for survival, or the selfishness, as Richard Dawkins famously put it. During the 1970s, E.O. Wilson created the field of social biology based on this idea, arguing that human behavior is influenced by genes and their impetus to reproduce. And I think that's true. I think that humans are influenced by it, but I don't think this is the sole form of evolution within the human domain. So let's get to that. When you get to modern humans, something really profound happens. This is the fourth wave of evolution. No longer is it the case that the human being has to make essentially all the same mistakes their mothers and fathers had made. Initially through spoken words, followed by writing in the social cultural matrix, ideas began to be passed along. This very capability within the mind of man sped up the nature of evolution, or increased on a vast scale the ability of the creature, us humans, to skillfully alter and manipulate the physical reality in which we live. So Richard Dawkins coined the term memes, and then this was followed along by sort of, John Beck's idea of spiral dynamics, where these value systems that are quite predictable to some extent, patterned, if you will. So within us, there's this still ongoing evolution that's happening very, very slowly. The evolution of vital life, we have that, plus this sort of or matter, and then this vital process. And then there's natural selection within us. We produce sexually. And then now we have this sort of cultural evolution within us.